What happens if gravity wins the ultimate celestial battle? It's time to talk about stellar black holes.
There are many types of black holes, like the supermassive black holes in the center of our galaxy, or rogue black holes that move through space, are hard to detect, and could come swallow a random planet without warning. But we're talking about stellar black holes.
Stellar black holes are the result of a gravitational victory against pressure, specifically the neutron degeneracy pressure keeping neutron stars going. And, as they say, the bigger they are, the harder they collapse under the force of gravity until their entire mass is compressed into a point smaller than the tip of a needle that warps space-time.
Welcome to Black Hole Anatomy 101. There are two different parts to a black hole that are important to know about if you ever want to impress a space nerd with some clever pickup lines. First, there's the tiny point of mass that is the reason the black hole exists, called the singularity. Theoretically speaking, you could compress anything into a singularity and create a black hole.
Isn't physics fun?
The other important part is called the event horizon. Think of this as the point of no return. Once you enter the event horizon, the force of gravity is so great that not even light is fast enough to escape.
And light travels faster than literally anything in the universe, close to 300,000 kilometers in a second, because in science we use the metric system, America. This means you can never see beyond the event horizon, because there are literally no photons to come out and collide with your retina.
It's just darkness and death down there.
Based on Einstein's theory of general relativity, gravity actually bends space towards mass.
This feels like a pull on the scale of a person, but let's think about the tiny scale of a photon for a second. Imagine a light beam traveling along through space in a straight line. Well, the light beam actually only thinks it's straight. Been there.
The gravity of celestial bodies warps the space surrounding them, and the light beam follows these curves. Also been there. Usually, stars and planets don't bend space enough to significantly affect a light beam's path. But black holes warp space so much that we can actually see beams of light bending around them as they pass by. This is called gravitational lensing.
Now, imagine a flashlight magically sitting at the event horizon of a black hole, pointing out, turned on. The beam of light wants to escape. The photons are speeding away in a straight line away from the black hole as fast as anything can move. But remember, the photons only think they're going in a straight line.
The space is so warped that this straight line is actually a circle, bent around the black hole.
Imagine walking in a straight line along the equator, minus the having things in your way and drowning part. You'd eventually get right back to the same spot because even though you felt like you were walking in a straight line, spoiler alert, the Earth is round.
The beam of light is forever orbiting the black hole, forever trying to escape.
For light inside the event horizon, even this purgatory is impossible. The only way to go is down.
So, when we talk about the size of a black hole, what we're really referring to is a shell, the event horizon, around the singularity at a specific distance, called the Schwarzschild radius, because that's the part we can see. The more massive a black hole, the more it bends space, and the larger its Schwarzschild radius is. In fact, the image of the black hole that was captured in 2019 shows the shadow of the black hole created from the disk of energy and matter circling it. That pure darkness with no hope at the center? That's where the singularity lives. And what we see is the event horizon. Black holes have quite the appetite. You thought the
Cannibal stars
was scary? A black hole can eat anything, even other black holes. And when a black hole cannibalizes another black hole, they just create a bigger and scarier black hole. But hey, maybe serenading this awesome display of gravity with an appropriate song will help you survive. Set me free, leave me be. I don't want to fall another moment into your gravity.
Just kidding. You would still die. Extra die. In fact, if you were to be so unfortunate as to be eaten by a black hole, your body would go through a process called spaghettification, a term coined by late great physicist Stephen Hawking. And it's exactly what it sounds like.
Your body gets stretched, tearing atom from atom, until you are just one long piece of human spaghetti at the bottom of a black hole.